Hi all, welcome to Quant tutorial. I'm your friend and instructor Saurabh. My aim through this particular channel is to provide anyone who wishes to do well in the competitive exams with the basic understanding of concepts and the underlying formulas to solve quant related problems in a quick manner. This will be beneficial for you if you want to crack competitive exams like CAT, GMAT, or GRE, or if you want to apply for any public sector jobs or any private jobs where the aptitude tests have become a quite a necessity. So let's get started. Our topic for today is permutations. For most of us, permutation seems to be a complex topic, but we can make it a simple and easy to understand topic for you. Let's see how. Okay. Before moving on to the permutation as a concept, I would like to give you the basic understanding of how to solve any of those particular problems just by looking at the question. Always take care of the words and or in the question. Okay, if they are not explicitly mentioned, try to derive the meaning of that particular question by transforming it to into your native language or try to understand what exactly the question is actually saying. If the question is asking for something like an and or sort of a thing, you need to multiply. If it's asking for an or, then you need to add. This concept is basically called counting. Okay, counting is simple and it is beneficial way for or an easy way for you to solve those particular problems. Okay, let's take an example over here. What exactly I mean? Okay, you have three pens and two markers with you. Okay, the pens can be P1, P2, P3. Markers could be M1 or M2. If I asked you that, okay, in how many ways you can pick any one of those items, your answer simply would be five ways. But if I try to understand that how I came onto that particular answer of five ways, it would be out of those three pens, I can pick one pen, right? And to pick that one pen, I would be having three different ways, right? I can pick P1, P1 pen, P2 pen, P3 pen. Similarly, if I need to pick any of those markers, M1 or M2, I can pick M1 or M2. Two ways. Since I need to pick any of those one items, I would be just 3 pen plus 2 markers, that is 5 ways to pick any of those one item. Let's say if I make it an AND question, okay, by saying in how many ways you can pick one pen and one marker out of the combination. 3 pens are there, I can pick one pen in 3 ways, 1 plus 1 plus 1. 2 markers are there, I can pick one marker in 2 ways, that is 1 plus 1. Now, the important part of the whole thing is an AND over here. I need to pick one pen and one marker, so I need to multiply things. 3 pens can be picked in 3 ways, 2 markers are there, I need to pick one marker, that can be done in 2 ways. So 3 multiplied by 2, that is total of 6 ways. Okay, continuing on to another set of questions over here, which would give you more clarity of this concept. Let's say you have 4 ways to travel from point A to point B. Okay, so you have to travel between from point A to point B. There are 4 ways to travel. You can think that this particular travel to be something like you want to do a car travel, you can want to do a bike travel, you probably have an option to do a plane travel or the railways travel. Okay, similarly, from point B to point C also, you have another 4 ways to travel. Okay, and my question over here would be in how many ways one can travel from point A to point C through point B. Okay, I need to travel from point A to point C using the point B. Okay, coming to the solution part. To travel from point A to point B, I can use only one way at a time. Easy enough. That basically means an OR condition. That is, I can choose from either of those 4 ways to travel and the total number of ways would become 4 ways. Similarly, to travel from point B to point C. Again, I have 4 ways to travel using any of those mode of movements. So the total number of ways is 4 ways, which can be obtained by addition. So the counting is something which we are doing over here. Now, to get the final answer, obviously I need to travel from point A to point C, which basically means that I have to travel from point A to point B and the point B to point C. So AND condition is there. I would multiply the answers which I have received from the point A to point B or from point B to point C travels. That is 4 multiplied by 4. So total number of ways which I can travel from point A to point C using point B is 16 ways. Okay, moving on to the next concept over here. Factorials. I would not be going deep down on what exactly factorial is because I would be taking a separate session to give you a much broader understanding of what factorials is. But from this particular perspective of this particular presentation or the permutations, I would say factorial is something which is a product of the first n natural numbers. Okay, it is expressed as n factorial. To give you an example, let's say you have to find out a value of 4 factorial, which would basically means 4 multiplied by 3 multiplied by 2 multiplied by 1. Okay, so you need to start from the number which is mentioned in the factorial till and have to go down one by one till 1. Okay, so 4 factorial would become 4 into 3 into 2, that is 4 3 12, 12 into 2 24, multiplied by 1, that is 24 again. 3 factorial would become 3 into 2 into 1, that is 6. 1 factorial is 1. 0 factorial is also 1. Okay, again, we won't go deep down into it, but that is what factorial is for you. Moving on to the concepts of permutations. Okay, what is permutation? Permutation is basically arrangement of things. So whatever the question actually says to you, that okay, you need to arrange people or 4 people in 5 different chairs or 3 different chairs. That is arrangement. You need to arrange words, 3 words into, 3 characters into a 3-letter word. Okay, that is an arrangement. So all of these questions would actually become the questions for permutation. Okay, another important thing to follow over here is whether in the question order is important or not. For example, order is important in case of problems related to password. Okay, you cannot have a password which is duplicate in nature. You cannot have a seating arrangement which would be duplicate. You cannot have ranks which are duplicate. So a sense of order is important in case of all of these problems. Okay. Now coming to the different rules which would help you answer all of these permutation related questions into all of these competitive exams quickly. You need to just get the sense of that particular question and understand it and apply the formula and all is done. Rule number 1. You want to arrange n distinct objects, right? So let's say I'll give you an example. Okay, you need to arrange books, 3 different books in a rack. Okay, you can do that in 3 factorial ways as per this particular rule. That is 3 into 2, that is 6 ways. Rule number 2. Rule number 2 says arrangement of n objects having some repetitions are. You can do that through n factorial divided by r factorial ways. Okay, I'll come to those questions and example stuff, how to explain all of these things a little bit later. So let's just go with the rules as of now, and then we can come to the examples part. The rule number 3 says conditional arrangement of n objects in r places. Okay, that can be done in NPR ways. P is basically sign for a permutation. NPR is something which you can categorize as n factorial divided by n minus r factorial. Okay, so if you have something as let's say 4p3, which would basically means 4 factorial divided by 4 minus 3, that is 1 factorial. So answer would be 4 factorial divided by 1 factorial, that is 4 3 12 24. Rule number 4. Rule number 4 says conditional arrangement of n objects where repetition is allowed now. Okay, so you have r places where you need to arrange n objects and the repetition is allowed. To get the answer of that number of ways, it would be n to the power of r. Let's see the questions now. How many different 3-digit numbers can be formed from the digits 1, 2, and 3? Okay, you need time to think. Okay, now to understand the question, I'm asking about, I need to create 3-digit numbers. 3-digit numbers are something like from starting from 100 till 999, correct? I need to create those 3-digit numbers using the digits 1, 2, and 3. In how many ways I can do that? I would use the rule number 1, right? I need to arrange n distinct objects, all of them, into those much amount of places. So the places over here are 3 only. I need to create a 3 place digit or a number using 3 different digits. So n and r are matching over here. So I would say my answer should be n factorial ways. N is equal to 3 factorial. So answer should be 3 into 2 into 1, that is 6 ways. So you can guess what the digits could be. It could be 1, 2, 3. It could be 3, 2, 1. It could be 2, 1, 3, 231, and likewise. Okay, coming to the next question. Okay, how many different ways we can arrange letters of the word book to form different words? I need to form different words using the letters of the word book. Okay, and if you see within that book word, actually there are only 3 letters. The letter O is actually repeating itself. So essentially, we have only 3 distinct letters. We need to make words of, but we need to make words of 4 letters over here. Okay. So basically, it's a case of, what is a case of? It's a case of repetitions. So O would be repeated within that particular solution. Okay. Rule number 2 of mine actually says that we will need to arrange n objects having some repetitions accordingly. So n objects over here are 4. There's a O letter which is repeating itself 2 times. So the number of repetitions is 2. So my answer for finding the different amount of words which I actually can create out of the word or the letters of the word book is 4 factorial divided by 2 factorial. That is 4 into 3. That is 12 ways. Okay. You can always go back to those particular slides to re-listen to that particular question and how we actually have put out the rules for those. Okay. Continuing to the question number 4 over here. How many 5-letter code words can be formed from the first 7 letters of alphabets and the repetition is not allowed? Okay. So first thing to understand is I have 5-letter words which I need to be formed from the first 7 letters of alphabets. That is A, B, C, D, E, F, and G. Using those first 7 letters of alphabets, I need to create only a 5-letter word. And another important thing to note over here is that repetition is not allowed, which basically means that we cannot have the words which are having 2 A's, 3 A's, or probably all A's. Okay, so that is something which is not allowed. Coming to the rule number 3, do you think that this would answer this particular question? Yes, it would. Conditional arrangement of n objects in r places. So n is something like 7 letters. R places is 5-letter code, so r becomes 5. And the repetition is not allowed. My answers could be based out of the formula called NPR, which is n factorial divided by n minus r factorial. So if I put all the numbers around it, it would become 7p5, that is 7 factorial divided by 7 minus 5 factorial, or 7 factorial divided by 2 factorial, that is 2520 ways. Wow. What if now I'll make this problem a little bit complex? I'll make the repetition allowed. Okay, so in this question only, if I add the clause that repetition is allowed, what would happen? Now, if repetition is allowed, the case or the code of 5 times A becomes a valid code. In this case, I'll go with my rule number 4, that a conditional arrangement of n objects where the repetition is allowed is n to the power of r. N over here is 7, r over here is 5, so 7 to the power of 5, that would be my answer. Okay. None of the times when you actually see all of these questions within CAT or GMAT or a GRE exams, they would actually ask you to give the proper number. So 7, they won't expect you to actually have to give you an answer of or by calculating what 7 to the power 5 is. Most of the time, the choices would always be 7 to the power 5. So it's easy that way. They know, those people on those competitive exams actually know that people have to have that particular answer in less amount of time. So they would actually never ask you to solve 7 to the power of 5. Okay. Moving on to the next question. In how many ways I can wear 3 rings in 4 fingers? Again, if I apply rule number 4 over here, where since the question actually doesn't say that okay, the repetition is not allowed or allowed, I'll assume it, or we will always assume it, that the repetition is allowed. Okay, so conditional arrangement of n objects where the repetition is allowed, rule number 4, we can say that there are n equals to be 3 rings which need to be worn in r equal to 4 fingers. So n to the power of r gives me 3 to the power of 4, that is 81 ways. Okay. Now, if I make this question a little bit change and I actually add a condition that the repetition is not allowed in the above question, what I would be actually doing is I would be falling back to rule number 3, which would say that 4p3 would be my answer. 4 is the number of fingers, 3 would be my 3 different rings, and 24 ways. You must be wondering over here that on the slide I have taken n as 3 on the first question. In the first part when the repetition is allowed, I have taken n as 3 and r as 4. So why did I actually change the n and 3 r values in the second part of the question? So as a thumb rule, n is always a greater than r. So you need, whenever you are picking up the values for n and r, to calculate the values using NPR formula, you need to be cognitive of this particular fact that n should always be greater than r. So you can change the points, change the values accordingly. Moving to the concepts number part 2 of the whole permutation problems. And this is basically when the objects need to be arranged in a circular fashion. Okay, when you want to arrange your objects into a circular table or circular fashion, it becomes a part of the circular permutation problems. For example, the number of ways to arrange 3 people around a circular table. Okay, let's say if I tell you that okay, there are 3 people, P1, P2, P3, and you need to arrange them into a circular table, tell me how many number of ways you can actually come up with. If I go with the rule 1, which we just talked about in our previous slides, it says that okay, n people can be arranged, all of them, in n factorial ways. That is, if there are 3 people, I can arrange them in 3 factorial ways. That is 3 into 2, that is 6 ways. And let's say if I come up with this particular combinations, how it would look like. Would they look like something like this? Yeah. So I would be arranging people into P1, P2, P3, P1, P3, P2, P2, P3, P1, and so on. But if you closely look, the top row of each of those numbers exactly look same as the bottom 2 rows. P1, P2, P3 doesn't differentiate if I'm using a circular table to P2, P3, P1. It's like arranging the same thing again. Similarly, P3, P1 and P2, it is also a redundant or a duplicate value of P1, P2, P3 on the top. So, in case of circular combinations, it's very important to actually have an order or not an order defined, that whether the order is important or not. To solve these, the formulas which need to take into account is rule number 5, total number of circular permutations of n objects if the order is important. That is, whether the order of clockwise or anti-clockwise is important, then the number of ways you can get the answer is n minus 1 factorial ways. That is, let's say if in this case only 3 people need to be sit around circular table, the answer should be 3 minus 1, that is 2 factorial ways, which would be 2 ways. So essentially, I would be having only and only 2 ways of solving this particular problem, that is P1, P2, P3 and P1, P3 and P2. In these 2 cases only, I would be having the distinct answer to the question. Rule number 6. The total number of circular permutations of n objects if the order is not important. When the order is not important, it basically doesn't matter that whether it's clockwise or anti-clockwise. Even in that particular case, the answer would be n minus 1 factorial divided by 2. Okay, so coming to the 3 persons in a circular table problem only, P1, P2, P3, P1, P3 and P2, those are the 2 combinations which we are left with. And if you see to it, if I remove the order, that is clockwise or anti-clockwise, actually P1, P2, P3 and P1, P3, P2, they actually mean the same thing. Correct? So, in that particular case, these 2 would also submerge with each other and we would be left with only one way in which the seating can be done if the order is not important. Okay? So, P1, P2, P3 becomes equals to P1, P3, P2 and we would be left with only one way. Let's see how to solve this in a question. In how many ways you can set 5 people around a table? Okay, slightly bigger number of people sitting in a table now. Rule number 5 says if the order is important and it's mentioned within the question that the order is important, then your answer would be 5 minus 1 factorial ways, that is n minus 1 factorial ways, and the answer would be 24 ways. If I say that the order is not important within the question, then the answer for this particular problem would be n minus 1 factorial divided by 2, that is in this case 5 minus 1 factorial divided by 2, and the answer would be 12 ways. Please keep on looking back over the slides to if you have not understood anything properly. So just keep reverting back to the slide and try to find out, okay, how these particular rules would help you in solving your problems. Thanks for watching this particular video. Please click on like and subscribe button below to continue learning Quant in a simple way. Also click on the bell icon if you want to get the next updated videos or the next videos on the next topic, new topics, whenever I'll upload them. If you have any questions, do comment back and I'll try to resolve them at a very short notice. Thanks guys. Thanks for watching.